Okay, we talked about arcs. And when we talk about the arc, we're talking about this part of the circle. It's going to be the arc of it. And the measurement of the angle. So we know this is an angle. Um, and if that angle is 87 degrees, then the arc is also 87 degrees. Okay, so the inside of that circle has to add up to be 360 degrees because every circle is 360, which means the outside of those arcs are also going to have to add up to be 360 degrees. So if we're talking about all the arcs, and I'm going to put the arcs in hot pink here. So if this angle is 38 degrees, then we know that this arc from Q to P is also 38 degrees. The one from M to N is 25 degrees because that angle is 25 degrees. So we're going to try to figure out just using process of elimination, and it's just like a puzzle like we talk so much about in geometry. It's just going to figure out the puzzle. Well, we know that every circle is 360 degrees. Well, if it has a diameter in it and it's cut through the middle, then we know this side has to be 180 degrees and this side has to be 180 degrees, has to total that. Well, if I've got two of these measurements here, we can just say, well, what's 180 minus 87 degrees minus 38 degrees? That leaves us with 55 degrees. So this angle inside here is 55 degrees and the arc is 55 degrees. Okay, so if this one is 25 degrees from M to N, the little box here from P to N tells me that that's a 90 degree angle. Well, if it's a 90 degree angle, then the arc is also 90 degrees. So then to find the arc length from Z to M, not the length but the degrees, sorry, we would take 180 minus the 90 minus the 25. And that would leave us with 65 degrees here, which means this angle is also 65 degrees. So now we have got everything labeled on this circle, whether they're wanting a angle measurement or an arc measurement, we're able to answer all these questions. Now just remember from our last one, if an arc is less than 180 degrees, then it is called a minor arc. If it's greater than 180 degrees, then it is called a major arc. And so when we're trying to classify them, that's how we're going to classify them, whether they're a minor or a major arc. If it's equal to 180 degrees, then it's a semicircle, which means it's just half circle. Okay, so from P to N. And remember, if it's got two letters in it, it's going the shortest distance from P to N. If it's got that third letter in it, that's the direction it's going. It's going to go from Z to Q to P. So it wants that angle that includes that Q in there also. So from P to N is this one, P to N. Well, we know that one is 90 degrees. It's less than 180, so it's a minor arc. Okay, now from Z going in the direction of Q to P, so Z to Q to P is, well, that's our semicircle, so that's equal to 180 degrees. R to Z is just this one, and we know that that one is 55 degrees. And it's less than 180, so we're going to call that a minor arc. Okay. Z to M to P. So we're Z, we're going in the direction of M all the way to P. So Z to M to P is another 180 semicircle. R to M, well, since there's no letter in between it, it's going to be the shortest route. So R to M is going to be from those two added together. 55 plus 65 gives us 120. And so that is less than 180, so it's also a minor arc. Okay. Now, N, Q to P. So N going through Q, change colors here just so we can, N going through Q, whoop, the other way, so sorry, messed that one up. N going through Q all the way over to P. So if it was the short route, it would just be N to P. But since it's the long route, we're going to go all the way around, N through Q to P. So it's everything pretty much but this 90-degree angle. So we can add up the 25 degrees, the 65 degrees, the 55, the 87, and the 38. And that would give us 270 degrees. That's greater than 180, so it's considered a major arc. All right, Q to N, so that's going from here, Q to N, so it's going to be your 38 plus 90, which gives us 128 degrees, and that is a minor arc. R to P, R to P is going to go from here, here's my R, all the way around to my P going in this direction, so it's 87 and 38. It's 125 degrees. So that is another minor arc. Okay, so let's look at example 2. Well, these are all labeled for us, but they're all labeled in terms of x. And we know that all of those together have to add up to 360. So let's add them all together. So we've got 3x plus 6 plus 3x minus 4 plus 6x minus 6 plus x. And we know this all has to equal 360 degrees. Well, let's add all our like terms together. So we've got 3x and another 3x is 6x, plus another 6x is 12x, plus this 1x gives us 13x. And then if we add our whole numbers, we've got a positive 6 and a negative 4, which makes 2, and then another negative 6, so 2 minus 6 is negative 4. So we've got 13x minus 4 is equal to 360 if we simplified all that. So we're going to add 4 to both sides, just solving for x here. So 13x is equal to 364. Divide by 13. So our x will equal 28. Okay, so that's the first question. What's x equal to? Well, x is equal to 28. So we know this arc from A to B is going to be 28 because he's just x. Well, let's just go on and fill in the rest of them. So this 3x plus 6, so that will be 3 times 28 plus 6. And that gives us 90 degrees for this one. 3x minus 4, so 3 times 28 minus 4 gives us 80 degrees. So this C to D is 80 degrees. 6x minus 6, so 6 times 28 minus 6 gives us 162 degrees. So that arc from A to D is 162. And if we add all that up, we should end up with 360. Okay, so now let's go answer the questions, because it's asking for the angle measures. Well, we know if the arcs are that measure, then we also know those angles are going to be that measure, so we can just follow those inside. So AEB, that's going to be 28 degrees. B to E to C, well, that one is 90 degrees. CED is 80 degrees. And DEA is 162 degrees. Which, that is an error on your notes. So that should be 162 degrees. Okay. All right, so now we're going to look at the last example. Let's just go ahead and label. We know F to Y then would be 55 degrees. F to D is 138 degrees. Okay, so remember a tangent line attached to a radius where that meets. Remember that? That's always 90 degrees. Okay, so if that one's 90 degrees, this triangle is 25 degrees here, we can easily find out what this angle is because we know all triangles add up to 180. So let's take 180 minus the 90 minus the 25, and that gives us 65 degrees for that angle measure, which also means that arc measure is also 65 degrees. Well, now we can easily find out what this angle XPD is. This one, because it's all going to add up to 360. So 360 minus the 65 minus the 55 minus the 138 should give us that last one. 102 degrees. So this one should be 102 degrees. All right, so now let's answer the questions. So the arc from F to Y, well, if the angle is 55 degrees, then the arc is also 55 degrees. Y to X, remember that angle measure was 65 degrees, so therefore the arc is also 65 degrees. F to D angle, 138. D to X was 102. All right, so it's asking for the measure of the angles. And remember, we just follow those along. So DPX is 102. XPY, so X to P to Y is going to be this one. It's going to be 65 degrees. And then P to X to Z. So it's asking for this one, which we know, remember, is 90 degrees because those radius out to a tangent line always creates a 90-degree angle. So again, it's just a puzzle. You're just having to figure it out. As you saw, I went and labeled everything inside my circle first and then went and answered the questions. So it might be good to sort of, put those pieces together and get that circle, get all those measurements all filled out, then go answer your questions. Just makes it a whole lot easier.